All right. All right. Thanks everybody for signing up and attending our final webinar of 2024. Um, this is the last in a series of webinars for 2024, where we are inviting people who weren't able to present at Suricon for whatever reason. And so I hope that you find it informational and engaging. Just a word about the OISF. It's a US-based nonprofit created to build community and support the development of Suricata. The funding for the nonprofit is primarily from other security organizations throughout the world, including folks like AWS, Proofpoint, and then other organizations. You can read more about it if you go to oisf.net and look for consortium members. A little bit of a plug for Suricata. It's more than just an IDS and IPS. Those are detection and prevention, IPS being inline. Not only does it do the alerting and detection capabilities that you might think of, but it also is a full-featured network security monitor and has the ability to do PCAP capture. You can learn more about Suricata and what it offers by going to our main website, which is suricata.io. So that is the brief introduction that I alluded to, and now Nacho is going to present his talk. Nacho has been with Corelight for a number of years as overseeing some of the machine learning and aspects of our product line. And he's found an interesting way to use machine learning and feature extraction to help hone in on a set of rules that might make sense for deployments. So I'm going to stop my screen sharing and turn it over to him.
Let me know if you can see it now.
Yep.
Ooh, thank you, Jeff.
Perfect.
And thanks everyone for joining, and to the Suricata team for having me here. So it's a pleasure to share these ideas. So the webinar is about, as Jeff was saying, about rule analytics and how we can use exploratory machine learning to better understand the rule sets, the Suricata rule sets, and also make decisions or more efficient decisions as to which rules are interesting for our use cases. So just a very brief intro on my background. I work at Corelight. I'm a director of data science. So I work with the labs team, which is the research and development team there. And I do have like close to 9 years experience now at the intersection of security and then data science / ML / AI. So mostly focused on detections, but also on providing better insights to network analysts. And what brings me to this talk is a project that we have been working on that consists in curating rules from several Suricata rule sets, mostly the ET Open and ET Pro. Where basically we had like this massive rule set and we need to make sense of it and extract the most value out of it for us and for our customers. And at the same time, this is a team effort. So here's the pictures of 4 of the key contributors to this project, and I'm sure there's more. So myself, and then special shout out to Youssef Lofty, who's an awesome ML engineer that has been working on this project. And then Travis Green, you might know him from the community, and Simeon as well. So for this talk, we first wanted to motivate like the need for exploratory analytics by talking about the pains of the rule set exploration and management. Then we're going to go through like a fairly typical data science workflow where we first start trying to understand our data with descriptive analytics, with plots and some breakdowns per attributes and so on. Then we're going to do like a feature extraction process where for each of the rules in a rule set, we're going to extract a series of analytics of features. And we're going to go into some detail about those. And then once we have that, the next step can be to cluster those so that we can get an intuition as to whether there are groups of rules that are similar, what those are, and so on. And then Finally, classification, which is if we have like a series of preferences for rules that we want to deploy or alert on, can we train models that can, for new rules, basically replicate those decisions and recommend rules that could be interesting for our use case? And throughout the presentation, we're going to be using the ET Open rule set, in particular, the one that was downloaded on the 29th of November that contained like 41.5K thousand, oh, sorry, 41.5K rules. And those were the active rules. So in this case, we did not consider those that were inactive. So the big pains, as you will all know, there are just a lot of rules in those rule sets. This particular case had like those 41.5K rules, but if you add that the ET Pro rule set and perhaps like other rule sets, then you might easily go into the 100,000 plus. So it makes it very difficult to basically go rule by rule and understand what's in there. To add to the number, you have variety. So you have like a very wide range of content and detections in those rule sets, which basically requires a lot of expertise to parse through and understand what the different rules are doing and what attacks they're after, but also what informational detections they're after. Also, there's different rule writing styles. Definition itself that is used for the detection in Suricata, but also to the metadata that is applied to the rules. So unfortunately, they're not always super consistent in how they're documenting or annotating those rules, which makes it even more difficult to analyze the rule sets. And then given that input, like very massive and with a lot of rule sets that are massive and with a lot of variety, the two big tasks that in my opinion are tricky is one is the initial tuning, is you start from scratch, you have a brand new deployment, what to do, right? Like what are the first rules that we want to deploy and what are the trade-offs there? Knowing, of course, that there's not one configuration or one set of rules that satisfies all use cases or all scenarios. Different networks will require different rules. And then the updates. So this is a constantly evolving, these rule sets are constantly changing and they thankfully keep getting updates. So it also puts some pressure on the people managing these rules because now you have new rules every day and you need to make decisions whether you want to act on those and deploy those and alert on those or not. So for the initial rule tuning, which I think it's the biggest challenge, at least the one that we were facing ourselves, which is how can we actually get to understand those rules to decide what to deploy? You have two big options, right? One is to tune in, which is you start from zero rules deployed or that generate alerts. And then slowly by little, you get familiarized with that rule set and start to add some more rules or deploy some more rules. And pros is that you manage to have control about of the noise and false positives, but the risk is that you will be missing things as you get familiar with the rule set because you will not be deploying all the rules. Otherwise, you can tune out, which is you start with everything and wait for it to explode in number of alerts and start to prune out the rules that are noisiest or that you consider are not useful for your environment. And there's going to be a very long tail of rules to get rid of over time. So we at least wanted to have control of the noise and false positives. So what we propose here is a tuning process that is more efficient than going rule by rule, right? That to facilitate that exploration of the rule set and getting familiar with the content of the rule sets. So for that, like for me coming from the data science world, the first thing to get familiar with a data set, in this case, this is how we are seeing these rule sets, is to break it down by the different attributes and see some distribution, some trends, some patterns. So first thing we realized when we started looking at the rule sets is that there's a lot of metadata that is very useful. Things like severities, class types, the traffic source, and so on. So we wanted to get a better sense as to how we can leverage those. So we started plotting basically the distribution of these different attributes for this ET Open rule set. For example, for the severity, you see that I don't know if you can read the fonts; they're fairly small, but this big bar is major severity. Then you have informational, critical, minor, and then a bunch that are not assigned, right? So already we see here that, okay, the metadata is not fully complete, unfortunately, and we kind of get a sense of severities. Basically, most are major, and which means that they're probably threat detections. Then you can do the same for traffic sources. You can look at the different protocols. Perhaps there are some that are more of interest for your use case than others. So you can get a sense here. There's many other ways to slice the data. For example, you can look at class types that tell you like the basically nature of the detect or the family of the detection. But you can also look at the message category, which is like basically the combination of the creator plus the high level category like malware, phishing, info, hunting, and so on. And they're a little bit related, but they're also sometimes orthogonal. So great metadata, but already we see that we have many options here to slice and dice the data. You can also look at when the rules were created, right? And you can think perhaps that older rules are of less interest, whereas more recent ones are more relevant for the time being. So that's another way to perhaps think of selection mechanisms to or selection policies to deploy or not deploy rules. More even, you can look at the confidence. This is, I think, fairly recent as far as I understand. But basically now the ET team is trying to provide like a notion of confidence in the rules, like how prone to noise each of the rules is. But you can still see that a lot of them don't have that tag, right? So there's a lot of high, medium, and some low, but many don't have it. And you might also then look for specific rule types, like perhaps rules that go after specific CVEs, and you can drill down into those. Or perhaps you can think of other considerations like performance, right? Perhaps there are rules that are more resource intensive than others. Perhaps if it has like a complex regular expression, or if it has a threshold, probably entails some state. So you can think of, okay, maybe for my use case, I want to look at it more from a performance point of view and focus perhaps initially on rules that are more lightweight to run. And the conclusion for us is that, wow, there is a lot of rich metadata here. At the same time, it's difficult to put it all together because there's many dimensions that we want to look at simultaneously. So the question that we were asking ourselves is, okay, we do have these rules. For the most part, they have like great metadata. How do we make the most out of all of that? And for us, it started thinking from a analytics or feature extraction perspective is thinking, okay, how can we characterize each of these rules, right, in the most comprehensive way? And we started to think of these analytics or features that would describe each of the rules. And we came up with a long list. So some of the features were extracted from the rule definition itself, like what is the traffic source? Is this an east-west rule or a north-south rule? What is the flow direction? Are there any exceptions that are hard-coded into the rule itself? We also looked at the metadata in the message field, right, to extract the author, the category in the message, so whether it's ET malware, ET phishing, and so on, severity, class type, specific keywords that could indicate things like C2 exfiltration and so on that tend to be high fidelity versus others like qualifiers like possible or likely or potential that perhaps indicate lower confidence. Then also we looked at the MITRE annotations, and then we looked at the rule also definition to see which fields were used to do the matching, right? For example, rules that match on the DNS query will be using that field, and we can leverage that to understand what the rule is doing better. And we extracted a bunch of those, basically different rules that could be matched. And now what we did is extract all these analytics or features for all the features, and that gave us like a very long data or wide data frame. I can't really plot it in one slide. In fact, this is actually 3 rows, and I'm copying like different columns in on the top and the middle and at the bottom. And there's also 3 dots here, so just basically just to convey that it's a very wide data frame with a lot of info in there. And our first instinct was, well, let's just filter and slice and dice this thing with a spreadsheet. So this allowed us to basically filter by the different attributes and then perhaps deep dive into specific rules by doing different filters. But it soon became like overwhelming too, because now we had like, I don't know, like 100 columns there, and it's difficult to keep track of what you have filtered, what you're looking at, and so on. So it did keep us going, and we were able this way to identify like rules that were very interesting for our use case, but it was not a sustainable solution for us. So the next thing that we tried was clustering. Is can we basically identify rules that are very similar in such a way that if we want, it facilitates the decision of saying, okay, if you identify a group of rules that are very similar, can you make like a joint decision for those as to whether they're interesting for your use case or not, right? So that's what we wanted to achieve, is basically reduce the number of decisions by grouping similar rules together. So what we did is taking into account all those features and analytics that we had extracted, right? Um, we ran it through different clustering algorithms. In this case, what we did is because we had like 100 plus, well, in this case, 249 numerical features that we had extracted, we first performed dimensionality reduction, which is you compress those many dimensions into a smaller space. And then that allows us to plot it on the one hand, and also to more easily cluster those. And then what we basically projected that into that two-dimensional space, performed the clustering, and then what we see in these plots, it's a color coding where each dot is a rule, and each color is a cluster identified by the algorithm. So for me, with my data science lenses, what I see is that these clusters are fairly disjoint, which is a good thing. It means that it's grouping rules tightly together. And that's what we want to achieve, right? Um, but at the same time, we're not being able to cluster all the rules. So here's a trick. What we want to achieve is those clusters that are very homogeneous, right? That have very similar rules. So we're using like a thresholding strategy based on the silhouette score. And silhouette score is basically a score given to each rule that tells it how closely it relates, or how close it is to rules in the same cluster, and how different it is from rules in other clusters, right? So what we want to have is very high silhouette scores, basically close to 1. And that means that if a rule has a very high score, it's very similar to the rules in its cluster. It's very different from rules in other clusters. And we can use that score to then basically open the gauge or close it. In this case, we are very conservative, and we're setting a high threshold of 0.7. And what we get is fewer rules that are clustered, because not all of them are tightly clustered, but those clusters are very disjoint, they're very homogeneous. So that's good. But at the same time, we're lacking coverage. So because we're being more restrictive, we were able only to basically group in tight clusters 20,000 rules out of 41.5K. Then if we relax that, we can add more rules to these clusters, but we see that those clusters are a little bit more scattered. So there's more risk of basically having clusters that are not fully homogeneous. But it's a trade-off here. So basically we relax that condition. We have more rules in there, like 27,000 rules. But as we said, those clusters might not be as good or as homogeneous. So to get a sense as to whether this is working well or not, I mean, these plots are nice, but let's deep dive into some of the clusters that were obtained this way. So, well, these are the names of the clusters. This is another thing that we're trying to do, is given the rules that are grouped into a cluster, we're trying to infer good names by looking at what are the most common words in that. So they're not perfect by any means, but it gives us a high level idea of what the clusters are about. So it's things like, for example, SQL injection, or spyware, or phishing DNS, or phishing successful, and so on. And then we're putting in parentheses, like in brackets, the message, the categories extracted from the message, to get a sense as to whether the rules are informational or threat detection rules. And now what we're going to do in the next slides is basically deep dive into some of these clusters. Well, actually, first, to get a sense of how many rules are clustered together, this is a distribution of the rules per cluster. So we can see, for example, that the biggest cluster is for SQL injection, and it has almost 2,000 rules. Then there's a bunch of informational rules for HTTP request, and that also groups it in a fairly large cluster with 1,600 rules. And these, in a way, like confirms our intuition that clustering is useful, because it's basically grouping a lot of rules together. So in the ideal case, we would be able to reduce the number of decisions a lot, right? Because instead of having to go rule by rule here, maybe we can look at the cluster. If all the rules are indeed similar, we can say, okay, do we want to make a joint decision for these 1,866 rules in one go? Or, I mean, do we want to deploy all of those or not, right? That's the ideal case we're after here. Yeah, and this is the plot for the when we relax the threshold, we see the the less homogeneous clusters, and the names change a bit, but we still see like SQL injection attempts. We still see like those informational HTTP requests, the phishing clusters, and so on. And here the distributions will change, like different number of clusters. So what we obtain is fewer clusters that will have a little bit more variety in them. But still, we see that the numbers are similar. We still have like clusters of several hundred rules in the worst case, and then in the best case, like close to 2,000 rules. Okay, so down to specific clusters that were identified in this way. For example, there was one that was very obvious, which is the known Tor IP addresses. There were 693 rules that were clustered together, and I looked at all the rules in this cluster, and they were basically identical rules that just basically are looking for a different set of IP addresses. So these are Tor relay IP addresses, right? And all you have like in the ET open rule set, you have like a bunch of those that look for those IPs. And instead of having all of it in one rule, it's broken down into many rules that were successfully grouped together in this cluster. I hope, by the way, that you can all see the the names, even if it's not the details, is to get the gist of it, that they're all similar rules. This one was the SQL injection attempt cluster. It had like 1,102 rules. And I also looked at them, and it was very, very homogeneous. All of them even had the keyword SQL injection attempt. So again, the logic here is, if we are interested indeed in SQL injection detections, right, can we just make a decision for all the rules in one cluster in one go, as opposed to having to go through all of them one by one? An interesting one for us was the CNC beacon. So there's a lot of rules that have the keyword check-in or beacon, and those were all grouped in this particular cluster. I did bring up this one because, as opposed to the previous two that were like very homogeneous, this one had a few what could be mistakes, because when I was looking at it, I saw that the categories were ET malware, ET web server, and ET policy. And the first two could make sense to me that they were joined, but ET policy was standing out because normally I wouldn't think of mixing those two. So I did some more deep dive to look at what were the policy rules that were added to that cluster. And it turns out that it was an adware one that had like the keywords also in beacon, right? So you could think of, okay, this might be borderline between adware, policy, or malware, because adware might or might not be okay in some organizations. But at the same time, you could think that the rule is fairly similar. It's probably looking for exactly, it might be composed in exactly the same way as a malware rule looking for malware beacon. It's just that it just so happens to be adware instead of like something more critical. And then the other two policy rules that were in the cluster were for cryptocurrency miner check-ins. Again, also using similar keywords, very similar definitions. It just so happens that instead of being malware, it was a cryptocurrency miner. But overall, it made sense. Like it had grouped together all rules that were basically having check-ins or beacons. And by the way, it's not like this is perfect clusters. We know that we are having to deal with thresholds and trade-offs here, but at least it does speed up the process of understanding the rules and identifying also those outliers in the clusters is fairly quick. Next cluster, a little bit smaller, but this basically was all phishing landing sites. And it's interesting because some of them were also coin miner, but they also had the keywords phishing in them. So that was interesting. And some of them were classified as ET hunting, but they were also like phishing landing sites. So it's interesting because that also tells us that the metadata is, or the categorization there is always not always super consistent, right? So being able to look at rules this way also allows us to make those connections, right? And those correlations of, okay, these rules are very similar, they're using similar keywords, but if we had searched it only by ET phishing, we could have missed some that were interesting as well, that maybe were labeled ET hunting. One more, this was an informational one. So for a particular use case, this was not um, like relevant, but it was still interesting to do the clustering because it did group a lot of informational groups together that were all basically looking at domain names in the TLS SNI field. So again, this could again be a case of speeding up the process of identifying rules that we are not interested in. So it not only works in one direction, it can also be used to identify rules to discard. Okay, so that's for clustering. And once we got to that point, this is our personal story, right? But we had used those spreadsheets to slice and dice the data, and then the clustering also to navigate the rule set and understand what were good rules for our use case. And we had built um, like a set of rules that we wanted to deploy. Not perfect, not super comprehensive, I mean, not fully comprehensive, but a good starting point. And now we were faced with a second challenge, right? Which is the maintenance of that rule set of that configuration. Because for what we have seen, like rule sets like the ET and ET Open and ET Pro, they keep adding new rules every day, right? So we need to make decisions for those. Yet we have already chosen and made decisions, right? So can we leverage those historic choices to inform what to do when we have new rules to analyze? And that's where we can use classification, which is like a different machine learning approach to basically learn from the past to predict or recommend actions in the future. Oh, sorry. So in our example, when we downloaded the the November 29th rule set, right? This was our current state of the world for us. So there were like these many rules, like the 41.5K. We had already made a choice to select more than 90,000 rules out of that and to discard 17,000 rules. And we haven't finished our homework there. We still have like 5,000 rules to, or more to, I mean, a little bit over that to decide on, right? But this is enough data for us to train a model. So what we did is we basically consider as training data to train a model like all the rules that have been analyzed and labeled so far. And to do that, we identify a cutoff point in time where we say, okay, from that cutoff point backwards, we're going to use that to train a model. And then from that cutoff point onwards, we're going to use the model to predict whether we want to leverage that rule or not. And the way we establish that cutoff is by looking at what was the last rule that was labeled and what was its create time. In our case, the last rule was labeled on November 27th, and that was the cutoff time for that. So any rule created on or before November 27th is going to be part of the training data. Any rule created after the 27th is going to be scored by the model that we create with the training data. And to train the model, we're going back to the same features and analytics that we were extracting and using for clustering. So same number, like 249 features. We are plotting here the rule SID and message, but it's not explicitly used. It's just to basically correlate the classifier decisions with the specific rules. And then what we do is we append the label, which is our historic decision as to whether we want to leverage the rule. And we're putting it as a 0 if we're not interested in it, and as a 1 if we are interested in it. And what the classifier needs to learn is, given these input features, what is the decision going to be, right? So you train a classifier with historic examples in such a way that now you have new rules, you extract the same set of features, and then the classifier can predict what the label is going to be, right? What the outcome is going to be. And of course, here I'm just showing a sample for simplicity, just like these few columns. But as I said, it's a wide data set with 249 features in here. So when we do that, I rerun this process today, right? And as of December 5th, right, there were 127 rules that for our use case were recommended by the classifier that were created basically after the cutoff point, after November 27th. And these are rules that had the top 15 rules with the highest probability. So we could see that in this case, the top probability ones are all malware rules that are matching domain names in the TLS SNI. And the probability of 0.99 is close to 1, it's close to perfect. It means that the classifier is very sure that this is a rule that we will want to deploy. Hence the message, basically recommended alert. It's a recent rule and on which we recommend alerting. And if you look at the dates when they were created, they were all after the cutoff point, right? So here I'm showing a sample of 15, but there were 127 of them. And in the next slide, I'm going to show like the bottom 15 rules that were recommended with high probability. So in this case, it's no longer malware, it's ET exploit kit rules. And it's some of them are looking for malicious domains as well, or at least domains used by exploit kits in DNS lookups. Others still in the server name field of DLS connections. And you can see how the probabilities are going down. In this case, we were using a threshold of 0.7 to basically automate this decision, um, and then and recommend these for alerting. So this is, I think, the most useful application for us at the moment, because we have these rule sets that are constantly evolving. It's too tedious to to go through those by hand. And with these classifiers, we're able to quickly surface rules that we want to add to our deploy or alert set. That said, there's another application of classification, which is we can not, instead of focusing on recent rules that have been created since that cutoff point, we can look backwards and do a retrospective analysis, trying to surface whether we have perhaps missed relevant rules, or maybe we have mislabeled some rules that we have labeled for alerting, but in fact, they shouldn't. And we can leverage also classification to do that analysis and get those insights. So in this case, instead of looking at the rules of training with the rules before the cutoff and then predicting on the ones after the cutoff, we just focus on the rules before the cutoff point. So that's basically the period of time in which we have applied labels. We have selected the rules. And what we do is we do tenfold cross-validation. So what that means is we're going to take that the rule set that was created before November 27th, and we're going to create 10 different splits of train and test in such a way that for each split, we're going to create one different classifier and predict on the left out set. And that way, each rule is going to be scored once. So then we have like a new probability for each rule, which is basically over cross-validation, what was the classifier saying for that particular rule? And we're using different ranges of probabilities to take different actions. So the first one is if the probability assigned by a classifier is very low and that label had been selected for alerting, then we mark it for manual review as, is this a rule that we should be removing? Because we say it's good for alerting, yet the classifier is thinking otherwise. And that's because it's likely very different from the rest of the rules used for alerting. So that could be mislabeled rule to review. If the probability is in that mid-range between 0.4 or 0.7, then we are flagging those for manual review. And basically, those are cases where the classifier is not certain like what the right outcome should be. And by the way, by labeling those, we also those are basically the best return on investment for labeling. So it's where the classifier is going to be tuned the most to our taste if we basically resolve its doubts, right? So when it's not sure, we go and give him like the ground truth. That's when it's going to improve more. And then the last one is if the probability is very sure that, if the classifier is very sure that this is a rule that we missed, that is not labeled for alerting, and that has a very high probability, right? Then it flags it as recommended for alert and being an older rule. And these are the ones we review to consider adding into our alerting set. And the output then is similar to what we were saying for recent rules. It's just that the creation date for those rules is going to be before the cutoff point. So here we'll see like rules anywhere from, I think in this slide, from 2016 all the way to 2024. And again, like different rule sets. I know what we're looking for in our use case. So I know that these ones are good guesses by the classifier. So they're all looking at malicious domains or in DNS lookups or the server names of DLS connections, which are similar to some of the ones we are flagging. So those were good ones. And again, this is a descending probability, so we can see how the classifier has like a different confidence for each of those. And then we can also go and do the opposite sorting and look at the ones where the classifier is least sure of this. And these are all rules that we were alerting on, and the classifier is telling us, well, this is very different from things that you're alerting on. So it looks like you shouldn't be alerting on this. And in this case, it's mostly CVEs. So it's true that many times we're not alerting on many of those. And I think that's what the classifier is flagging those. It also identified like some informational rules that I think were um, good findings that perhaps we will eventually will need to remove from our alerting set. Okay, so that was it for classification. And to wrap up like the presentation, I just wanted to share some key takeaways. First one is that for us, what really made a difference was when we started transitioning to extracting features and analytics from the different rules and basically looking at those rule sets as data sets, right? That could be slice and dice or that could be model. Basically looking at rule sets as data science problems and being very rich data sets was very useful. A note there is that the fact that they're annotated with very rich metadata is great. And the more consistent that metadata is, and even the style of the rule writing is, then the better it's going to be for downstream analytics, for management, and so on. Then clustering methods were of great help for us. So for one, it allowed us to basically get like a very clear or very quick insight into the types of rules that are in the rule set. Like what are the types and families of the rules and what are their proportions, right? What are the numbers? Like that way we have a very good idea of how many SQL injection rules there are versus how many malicious domain in DNS lookups and so on. And that allowed us to speed up the process of selecting our rule set, right? By basically making joint decisions for the rules in those clusters. And we hope that that could be of use to other people building their rule sets. And finally, classification, for me, like I think the best use case is automating the selection of recent rules. So the rule set is updated what to do with new rules, right? And this allows to simplify the process in a way because you don't have to create manual policies there. As long as you have already made the hard work of selecting like a rich rule set, a classifier should be able to let you know whether the new rule is very similar to those that you have selected or not. And at that, I think classifiers excel. They're very good at doing that. And then, as we have seen, we can also use these classifiers to surface historic or past incorrect selections, right? So we can basically confront the choices we have made and have a classifier tell us, well, this looks like it stands out because it's not like other rules you had selected, or otherwise it seems that you might have missed these other rules that is very similar to rules that you did select. And with that, I think that's all. So happy to answer any questions, doubts.
Well, hey, thanks for a great presentation. Folks, if you have any questions, go ahead and use the Q&A feature of Zoom to enter those in, and we'll get those addressed. I have a question that came up while we were doing this, and it had to do with looking at the retrospective side of it. Would, for the retrospective purposes, would it help to deploy the full rule set and make an observation on what is actually occurring on their network? Because one of the things that I would worry about is whether there's this one rule that's really vital that we somehow missed through this process. So is observation part of a feedback loop into this?
Yeah, so I think it needs to be. So this is just a way to speed up some of the selection, like that you do initially, right, with the initial selection. But then, of course, like if there are rules that, for example, are very noisy, yeah, by all means, go and get rid of those, right? And then if you have the luxury of being able to deploy and observe for a while, right, then by all means do that and see whether there are some rules that catch your eye as well, right? Uh, so I think it's easier to do for false positives in noisy rules than the opposite, right? Because if a rule is noisy, you're going to immediately see it, right? But if a rule is very critical and doesn't trigger, right, how are you going to realize that it's missing, right? Or that the rule is very important, right? I think that's also why getting a good insight into the rule set is important because you can draw these correlations. You can say, oh, these rules have triggered and they're very important. Can I identify other rules that are very similar to those, right? Because those might be of interest to me, right? And this clustering and classification approach can give you that.
Thank you.
We have one in the chat. Are the scripts for classifying open sourced?
So yeah, so this is something that we are at the moment discussing. So I think we will get back on that one. So can I ask, will there be like an interest in that? By the way, like all the things that I have shared here, right? They're based on notebooks and logic built on top of open source libraries like scikit-learn and others, right? So so could we perhaps like get a sense from the audience whether there's an interest in this type of approach or whether it basically resonates with their use cases?
Let me see if I
Yeah.
create a poll real quick.
So folks on the line, the question is, would you be interested in a sequel to this that is perhaps more concrete with using a Jupyter notebook and give some of the examples that go into building the feature set and doing the clustering and so forth?
I'm trying to create a poll. If we can't have it answered online, at least I think Zoom will send that to the registered attendees so we can gauge that. The person who had asked about the scripts said vehemently yes. And they said also that they are in direct contact with Perlite. So I think you have someone pushing to help you with open sourcing that.
Yeah.
Cool, sounds great.
Right. Another person saying the same. And they are in the process of deciding how to select rules and automating their processes.
Oh, awesome.
I have a question. I don't know if it's easy or not to answer, but have you tried to measure the productivity impact of using this?
Sorry, so when you say impact, in what sense?
In terms of time saved, or you
Oh,
see.
yeah, so I haven't measured it, but as part of the team that was basically digging through the rule set, I think it had like, I would say like more than linear speed up, or because what happened is, we were going rule by rule, trying to even decipher what was inside, right? So the first thing is with the slice and dice with spreadsheet, we were able to go from those 40,000 rules to perhaps identifying like a few thousand that we liked, right? And then with clustering, all of a sudden it's like we turned on the lights, right? And we were able to fully understand what was in there. So that basically allowed us to go so much faster. And then I can also say that so that was for the initial building of the alerting set for us, right? But then for the new rules, I think that's where we're gonna get like the most benefit in the long term, right? Like, so if we manage to have like a good classification approach such that classifications with very high probability we can automate those, it's going to be very good because we're going to reduce a lot the time that it takes. I mean, the delta between the time when a rule is created to when it starts to generate meaningful alerts for ourselves and for our customers. So sorry, not a very concrete answer, so I don't have numbers, but it did help us a lot internally.
Oh, no need for numbers, just to if you can already feel it, I think it counts a lot. Another one, and I don't know, again, if it's good or not, but I saw that you had the manual label in that column. Do you have a number on how many rules were manually reviewed like that to add that label?
Yeah, so I think I was sharing like our current state for so this is for
Yeah.
And we also do have like similar numbers for the ET Pro, right? In this case, I wanted to focus on the ET Open because it's something that the audience can replicate, right? It's open.
Mhm.
Um, so yeah, this is roughly it. And and what we did internally is to go after these clusters, these groups of rules, right? And then we didn't want to, we wanted to be a little bit cautious, right? So we went incrementally, started to add more and more and see the impact that it had in our deployments, right? And then over time, we kept adding some of those new groups of rules to see what,
Oops.
yeah, bad timing, to see that the noise levels were still under control, right?
So,
And this is an ongoing process. As I said, we still have like some rules to go through.
so all of those like 30 something almost 40 rules were manually reviewed and labeled,
Uh,
or just the clustered ones, the clusters.
so it has a mix. So initially it was
Okay.
more manual, and then it was more, we were able to identify perhaps groups of hundreds or thousands of rules that were very, very similar, and we were able to bulk label if you want, right? And that was thanks to the clustering approach. Yeah.
That's awesome. Yeah.
Yeah. I have another question. Is there anything that our friends at Proofpoint can do to make this job more streamlined, perhaps by schematizing portions of the metadata or something to include better information or more information that might help with a process like this?
Uh, yeah, so first of all, like I think they already provide like a lot of very good metadata, right? And I think their philosophy is it really is the consumer responsibility to make the most out of the rule set. Because again, some people might be after detecting threats with very little noise. Some people might be after informational detection. Some people might be after might be driven by performance considerations, right? So it's difficult for them to satisfy all use cases, right? For one thing that will be common across all is, as I was saying, like the consistency in the metadata will certainly help. Like if, for example, we could have like MITRE tags for all the rules, right? I know they're working on it and it's a challenge, right, to do that. But some rules have it, some don't. The confidence that was recently introduced, for example, is not present in all the rules, right? So it helps if everything is consistent. And also one thing I realized is that um, and I think this is a known thing in the Suricata community too, but some rules, they're not making the full, or some rules are not making the full use of all the fields that are available for matching. So even though Suricata can match, for example, on DNS queries, it's possible that rule writers are basically matching the string against all the DNS packet, right? Like the domain against all the DNS packet instead of focusing on that. So the rule is a little bit less informative because we know it's looking for a string in a packet as opposed to having the finer information of knowing that it's checking only the DNS query, right? And that would allow us to do better grouping as well.
Thank you.
Does that make sense?
Yes, yes.
We do have one in the Q&A. Any tips on how to deal with a fresh deployment when balancing performance with relevant rules? I assume that this classifier is not available for commercial use.
Yeah, so for like initial tunings, right? Um, what we did and worked for us at least is we started with I would recommend doing the clustering first and basically deploy perhaps one cluster at a time, right? And enable one cluster at a time. So if you manage to get like a group of a few hundred rules that are very similar and then deploy those, see the performance impact of that, and then move on to the next. I would say that there's also for performance, you can kind of anticipate whether the rule is going to be performing or not. So if you deep dive into the ET Open rule set, there's a lot that are indeed threat intelligence rules that are matching against IPs or domains. Those tend to be fairly lightweight. If you realize that the rule is looking for regular expressions or has thresholds, odds are that it's going to be more intensive. And then the question as to whether the classifier is available. Well, I think it's part of that open source in discussion and the follow-up. So hopefully we can have that follow-up webinar and we can share it there.
I hope this answered the question. I did create the form. I think it will be sent to the registered attendees, and as soon as we have results there, we've shared those with you. And I will not step on Jeff's next session of the webinar, so I'll just cut up here.
Okay.
Do we have
All
any more
right.
questions? I think we're good.
Okay. All right. Well, thank you very much for a very interesting chat. I am going to do the wrap up. And I don't have that one right. I'll try one more time.
While you were looking, Nacho, we are very pleased to see you wearing the Suricon t-shirt. And Kel said that she hopes to see you in Suricon 2025 too.
Well, I would love to. I had the best time in Madrid. Yeah. I'm
Awesome.
originally from Madrid, by the way. So for me, it was very special to go there. Yeah.
It's coming home.
Yeah.
So everybody, thanks for joining today. This kind of wraps up the 2024 series. We'll have something similar for 2025. No dates as of yet, but I do want to urge all of you to consider becoming more active with the Suricata community. We have a number of ways to get started. You can look at suricata.io for what those are. One of the biggest things is just to use Suricata and give us some feedback. There's also we have a Discord and a discourse channel. So you can use the forum to post questions. Or you could, that's quite searchable. And then there's a chat-like feature with Discord. And use those links. We'll distribute the slides later. Use those links to get started. They're also at suricata.io. So thanks again for 2024. We've done 5 webinars. We hope to meet or exceed that next year. We've had 4 community roadmap discussions where we've heard from folks who are users of Suricata and who have an interest in extending it and improving it for their use. And then finally, our Suricon, which was held a few weeks ago in Madrid. We had a record best 30 combined talks and lightning talks. It was a well-attended event. What's coming up? So in 2025, we're going to have Suricon in Montreal. That is expected to be in the late October, early November timeframe. We don't have any specific dates yet, but we will announce those as soon as we have them. We'll also be issuing a call for talks if there's anything that you want to present to the broader community. Also, Suricata 8 is due for a beta release in the spring. We don't have a specific date yet, but it will be in the spring of 2025 with an anticipated release date in the summer, June, July, or August of 2025. So thanks again for joining. The poll will be sent via email, and if you have a few moments to fill that out, please do. We'd love to hear your feedback. And Nacho, thank you for a wonderful presentation this morning. It was a pleasure having you, and hopefully there's some interest and we'll be able to do a part 2 in 2025.
Absolutely. Thanks for having me.
Yes.
Thanks, everyone.
Yeah, thank you. I'm going to pause recording.
Yeah, and we